Okay, so in this video, I'll be going over how to find the simplest polynomial function given its graph. So to the left of the screen, we can see that we're given a graph. It has zeros at -2 and 3 and has a y-intercept at -6. So what we're going to try to do is we're going to try to figure out what the function of this thing looks like. So for most students with this, they already kind of understand that if we have zeros here, we have zeros at x equals -2 and 3. So then what that looks like in factored form, we're going to have x plus 2, x minus 3. So most students can get that far right away. And a lot of the times they'll stop and say that this is what our function is going to be. So what they're going to say, f of x is going to equal x plus 2, x minus 3, which is part of the way correct, right? This function most certainly has zeros at -2 and +3. The problem is we also have this other point that just so happens to also be the y-intercept at -6. So we kind of need to force this thing to go through that point. And so what most students forget is that there is a hidden a variable in front of all this stuff. And so what we need to do is we need to find it. So what we can do is we're given this point 0, -6 down here. And if it gives you another point, say it was up here or something instead, and let's say that was like, I don't know, 4, 3 or something, you would use that point instead, but that's not what's given. So, what we're going to do is we're going to be able to plug these values in. So recognize here that this is a point, the form x comma y. So x is going to be 0, y is going to be -6. So we can plug all that stuff in. So f of x is another way of just saying y, so we can plug in -6 for that. And now a is still what we're solving for. We don't know what that is. And now we get to plug in 0 for all the x's. So 0 plus 2 is going to be 2 still. And then 0 minus 3 is just -3. So now we've got this, -6. We can just solve for a. -6. Oh, I didn't mean for that to happen, but turns out a equals 1. So I guess we can just plug in 1 for a. Oh, one more thing that I forgot. Notice here at the 0, -2, right over here, notice how it bounces off of off the x-intercept. It kind of hits it, it touches it right at the x-intercept, and then it goes back down. Notice here at the 3 over here, where the 0 is at 3, notice how it goes straight through it instead of bounces off it. So when it bounces off like it does at -2, you're going to have a squared on top of your 0. So here at the x plus 2 here, we're going to have a little squared here. And if it goes through, it's going to be just a 1. So we can leave that alone. And you kind of think of it like this. If we have just our typical x squared function, right here, it just touches at the x-intercept at 0, and it has a squared on it. So you can kind of think of it that way. So then I guess this would pretty much just be our completed function. You can kind of just X out this A and you'd be done there, because if you plug an A in, you're just going to get the same thing here. So usually it won't work out that nice. It just kind of happened to here. So that's how you would do one of these problems.